distributive property. The distributive property is multiplying a sum or difference by multiplying each term separately and then combining their products if possible in order to simplify. So if we look at example 1, based off of orders of operations, it's telling you to do inside of your parentheses first. However, if they're specifically telling you to work with the distributive property, we're not going to do that. We're going to multiply this coefficient to each term inside of this parenthesis. So when I rewrite it, I did 4 times 7 plus, because I have my plus sign, 4 times 5. So now I'm going to multiply them together. 4 times 7 is going to give me 28, plus 4 times 5 is going to give me 20. So when I simplify this, I end up with 48 for my answer. So the ones where there are just constants are the ones that are tricky because they want you rewriting it and then solving it instead of solving it first. You can always check to see if your answer is correct by performing order of operations. So my 4 gets carried down. 7 times 5 is 12, or 7 plus 5 is 12. So then when I multiply them, I get 48 as well. So pay attention to what your directions are actually asking you to do. For example 2, again, I'm going to do my distributive property. So I'm going to do 2 times x minus 2 times 6. So when I multiply these, 2 times x is going to give me 2x. I bring down my negative, 2 times 6 is going to give me 12. So your final answer is going to be 2x plus 12. I can't combine these terms because this one has a variable and that one doesn't. If we look at example 3, again, I'm going to do my distributive property. So I have negative 4 times my x, here's my minus, negative 4 times 2. So now when I go to solve these, I have a negative 4x. When I have two negatives touching, remember we changed this to a positive, so I'm going to have a plus. 4 times 2 is going to give me 8. Again, I can't combine these terms because the negative 4 has a variable and the 8 doesn't. If we look at example 4, again, so in this case you see that we have 3 terms. The process stays the same. This 5 is getting multiplied to each of these 3 terms inside of my parentheses. So 5 times my 3x squared, a plus sign, 5 times 2x, a minus sign, 5 times 6. Don't write it as 5 times a negative 6 because you've already used this negative sign when we write out our problem. So now coefficient times coefficient, 5 times 3 is going to give me 15. I still have x squared, plus 5 times 2 is going to give me 10x, and negative 5 times 6 is going to give me a negative 30. If we look at example 5, when I'm multiplying, I have 5x times 3x, and I have plus 5x times a 6. So when I solve these, 5 times 3 is 15. In this case, I have x times x. When you multiply variables, you add their exponents, so it's going to be 15x squared, plus 6 times 5 is going to give me 30. I only have one x, so I still have one x. In this case, we cannot combine these because this has an x squared and this has a single x. So since their exponents are not the same value, you can't combine those terms. For example 6 and 7, they want you to do mental math. So you're going to take the value outside of the parenthesis and write it similar to our example 1 in this expanded form to help make the math easier mentally. So 900 is the same thing as saying 100 minus 1. Since I've changed it into a subtraction problem, I've now made the math easier because 8 times 100 is 800, and 8 times 1 is going to be 8. So now if I take 8 away from 800, I get 792. This was faster than doing 99 times 8. Okay, it makes the mental math quicker. For example 7, if I have 24, I can expand 24 a couple of different ways. If I write it as 20 plus 4 times 6, 6 times 20 is 120 because 6 times 2 is 12, add your 0, and 6 times 4 is 24. So now I just have to combine them to get 144 as your answer. So if you can visualize rewriting these or splitting them up either as a difference or a sum to get that result, it's going to make the mental math much quicker for you to solve.